Jai Hind, dear students. In previous chapter we have learned about matter in our surroundings and their classification on the basis of physical properties. We know that matter are classified into three states on the basis of physical property, but in this chapter we are not going to learn about the classification on the basis of physical property. We are going to learn matter are classified into different categories on the basis of chemical properties. So, as we know, anything that occupies space and have mass is known as matter, right? So, whether it is visible or not visible, if the substance is occupying mass and have uh, any space, occupying space and have mass, it is matter. Matter is classified into two categories on the basis of chemical properties, pure and impure substances. Now, we are going to learn about the pure and impure substances. Like, as we know that impure substance means any additive substances are impure, but this is not true. We know milk is pure, but you don't know about the fact of milk, that milk is not pure substance. We are going to learn. It is shocking, no? So, what are pure substances? Pure substances that consist only one type of particles. For example, like water, carbon dioxide gas, oxygen gas, these are pure substance. But milk is not pure because it consists protein, fat, globules, water. So that is why the milk is not considered as pure substance, because it consists more than one substances. And a mixture can't be a pure matter, but mixture is made up of pure substances only. Like this is copper. Copper is matter and it is pure substance because copper is made up of small particles of copper type only. No other metal, no other elements are mixed in copper. That is why the copper is pure substance. And we have another examples of pure substances. You must have observed the oxygen. Oxygen is pure substance because its formula is O2 and it consists only oxygen type atoms. Here you can see water. Water is also pure substance because it consists hydrogen and oxygen type atoms, and it form a molecule, and molecule is a type of pure substances, right? So water is not impure because the proportion is fixed, it remains fixed whether the source can be changed. Now see about mixture. Mixture are also known as impure substances, and impure substance consist more than one type of particles. Like air. Air is the mixture because it is a combination of so many different type of gases. Like oxygen is there, carbon dioxide is also present, some other gases like nitrogen is also present. So different type of gases are present in air, so air is mixture. Here you can see tea and different substances. Tea is a mixture of tea leaves, sugar, water, milk, and the another example is soil. Soil is a mixture of insects, grass particles, water particles, and lot of microorganisms are also there present in soil. All these examples are of impure substance या mixture. Soil, tea, air, these are known as mixtures. Now, matter, this is the classification of matter on the basis of chemical property. Matter is categorized into pure substance, and pure substances are also of two types, elements and compounds. Like this water. Water is compound because it consists different type of atoms in fixed proportion. So it is, the water is pure substance. And I have given the example of carbon dioxide, that is also compound, or we can say molecule, because it consists carbon or oxygen type atom in fixed proportion. Whether you will get carbon dioxide from the burning of substance, whether you will get the carbon dioxide from air, the formula or composition remains same. So water and carbon dioxide both are the example of pure substance, and we can't separate these particles physically. Like water, we cannot separate it manually, physically, and these pure substances can be separate by only chemical methods. Chemically, we can separate these pure substance, but physically, it is not possible. I hope it is clear to everyone. Now, see the example of impure substances. I am going to give some example of impure substances. Impure substances is a composition of pure substances. This is the example of impure substance, like salt. Salt is made up of sodium and chlorine. So it is this is the composition of fixed element, so it is pure. I have told that it was impure, but it is not impure, it is pure substance. Salt, water, all these are pure substances. And sodium, chlorine, both are element. In this, see helium, oxygen, hydrogen, oxygen, these are elements, and these elements are pure substances, and when these elements are combined, they are forming molecule. And molecule when form, it always form in a fixed ratio. The source can be changed, but the composition or ratio cannot be changed. That is why all these are example of pure substances, or we can say elements and compounds both are pure substance. Now, as we know, pure substances are of two type. In the same way, mixture is also categorized into two category. One is homogeneous mixture and another one is heterogeneous mixture. Now see what are homogeneous mixture. When all the constituent particles are throughout same and dissolve completely in the solvent is known as homogeneous solution. You can see in the figure, like the yellow color is completely dissolved in water. So it is homogeneous solution. Here the another example of homogeneous, we are dissolving sugar in water. So sugar, that substance is dissolving, is known as solute, and the substance in which anything is dissolving is known as solvent. So solution is consisting two parts. One is known as solvent and another one is known as solute. This is the type of heterogeneous mixture in which you can see sand is settled down in the water, because we can see the sand is not completely dissolved, the composition is not throughout same. So the mixture of soil and water, sand and water are example of heterogeneous mixture. I hope it is clear to everyone what is the meaning of homogeneous and heterogeneous. And when we filter these substances, the heterogeneous substance always form residue on the filter paper or strainer, but the solution that is homogeneous is clearly passed through the small holes of filter paper, and these are homogeneous solution. Now these homogeneous solutions are known as solution, and as I have already explained, solution is consisting two parts. One is solute and another one is solvent. solute is always present in less amount and the solvent is always present in the more or large amount. For example, if we will take 10 ml of oil and 20 ml of water, and when we mix these water and oil, in this solution oil is the solute and water is the solvent, because oil is present in less amount and the water is present in more amount. Okay, as I told that the quantity of solute will always less and the quantity of solvent is always in more amount, right? Now see the interesting thing about the homogeneous solution. आपने अपने घर में बहुत सारी चीज़ें देखी होंगी, जैसे जब हम लेमोनेड फॉर्म करते हैं, लेमोनेड बनाते हैं, तो लेमोनेड में हम शुगर यूज़ करते हैं, वाटर यूज़ करते हैं और सॉल्ट भी समहाउ हम यूज़ करते हैं। तो इसका जो मिक्सचर जो भी फॉर्म होता है, दिस इज़ कम्स इन द कैटेगरी ऑफ मिक्सचर, but it is homogeneous. Homogeneous means you cannot identify where is the sugar particles, where are the lemon particles and where is the water particles in solution. So solution means homogeneous always, and this the mixture of water and sand is not solution. This is known as suspended solution. Suspended solution means the solution in which solute is not completely dissolved and it is settled down in the bottom, or the substances maybe float on the water. So these type of solutions are known as suspension, or these comes in the category of mixture. Solution is also mixture and the suspension is also mixture. So as we have seen that solution consists two parts, solute and solvent. In the same way, suspension also consists two parts. One is known as dispersed phase and another one is known as dispersion medium. Now see, suspension and colloidal are the another example of mixture, and these both are heterogeneous solution. In solution, or we can say true solution, the size of particles are very small, like sugar and water, and it form a single phase. Single phase means distinct boundaries are not observed, like in the mixture of oil and water we can see the separation boundaries, but in solution distinct boundaries are not visible. It is known as single phase. Colloidal solution particles are little bigger than the true solution. In suspension the size of particle is very big. So on the basis of size of particle we can categorize this matter into true solution, colloidal solution and suspension. Now another very interesting thing, the size of true solutions particle is very small. Do you know what is the size of particles of true solution? It is 10 to the power minus 9 meter. This size is, this magnitude is very small, and we cannot see these particles with our naked eyes. On the other hand, colloidal solution, the size of colloidal solution is bigger than the size of true solution, and exactly the magnitude of these particles are in between 10 to the power minus 9 to 10 to the power minus 7. The third one is suspension. The size of suspension particles are bigger than true solution and colloidal solution, and this is equals to, or we can say it is more than 10 to the power minus 7. Now if we apply the light from these three solutions, we will observe an interesting fact The name of that fact is Tyndall effect. Before the Tyndall effect, I want to tell you about some another fact about these solution. Appearance of these three solution. We can see true solutions are clearly visible, means these are transparent. These form transparent solution. On the other hand, colloidal solution like milk is not transparent. Another colloidal solution is blood. Blood is also not transparent. So we can say the colloidal solution forms translucent solution. Translucent, everybody knows the meaning of translucent, from which we cannot see clearly the objects. Now we will talk about the suspension. Suspension's particle size is very big, like chalk and sand. So these form opaque solution. If we will add soil in water, it form opaque. We cannot see the object, which is another side of suspension. Now filtration criteria. What is the filtration criteria of these three solutions? True solution completely filtered through the filter paper. Nothing is left as a residue on filter paper. And colloidal solution. Colloidal solutions form, when we filter the colloidal solution, some residues are left on the filter paper, because the size of holes of the filter paper is very small. From these small holes, colloidal solutions particles cannot cross. And when we filter the suspension solutions, also we have already seen in the lab that if we dissolve chalk in water and when we filter with the help of filter paper, chalk particles left behind over the filter paper. So this is known as filtration criteria. These all three points are very important: appearance and filtration criteria. And the next one is, now we will talk about Tyndall effect. See, when we are applying the light on these three solution, light clearly cross the true solution because particle size is very small, but the light cannot pass through the colloidal solution and suspension solution. What is the reason, you know? Because the size of particle is big of colloidal and suspension. When we apply this light, this light is a strike on these particles and bounce back. That is known as reflection. Due to the reflection, the light is visible inside the colloidal solution and suspension solution. But in true solution, light cannot be visible because light is not reflecting. Why it is not reflecting? Because the particle size is very small. Light particles are also small and true solutions is small. So these particles cannot bounce back and the reflection does not occurs in solution. And as we know, when reflection occurs, the things are visible only then. So this effect is known as Tyndall effect. Tyndall effect you must have seen at your home, in especially in winter season. When we open our windows, some light enters in our room. Along with the light, some dust particles also you can see in the light, and these particles, dust particles, are suspended in the air. So this is also Tyndall effect. And another example of Tyndall effect is when we used to do dusting at home, we will see these dust particles in light. So this is also Tyndall effect. Again, the solute and solvent form solution, and colloidal solution, dispersed phase and dispersion medium form colloidal solution. कोई भी चीज़ जिसमें घुली होती है उसको हम कहते हैं डिस्पर्स्ड फेज, और जिसमें घुली होती है दैट इज डिस्पर्जन मीडियम. लाइक डिस्पर्स्ड फेज इज सिमिलर टू सॉल्यूट एंड डिस्पर्जन मीडियम is similar to solvent. Now see in the suspension. Suspension also consists two parts, that is suspended particles which are dissolved in solvent, and the solvent is known as suspended medium, right? So these terms are very important. Suspended particles are dissolved in suspended medium, and this combination is known as suspension. Like the mixture of sand and water. Sand is suspended particles and water is suspended medium, and these both combine and form